gentlemen, have a short presentation on the solar eclipse, and let me introduce Bernard Arghiere.
Thank you, Dominic. And before I start, this is a very abbreviated version of a longer presentation I've done, but Dominic asked me to get something that we could present to the club in a short fashion, but still cover many of the highlights of this upcoming eclipse. Much of what you're going to see, you can also find on the club's website. There's a page on the menu that's dedicated just to this eclipse, the 2017 eclipse. It has many of these slides, maps, and diagrams, so you'll be able to find them there. Some of them are interactive, so if you get on the website, you can play around with them a little bit. So yes, everyone already knows August 21 is a big day. We're going to have the first total solar eclipse visible in the 48 states since 1979. That was my second total solar eclipse. I was living in California, drove up to Eastern Oregon with a buddy, got in the desert. There wasn't a car around. Nobody was around. It was like no one had even heard about it. But that's not going to be the case this year. Oregon's already complaining that all these people from Seattle and Washington, millions of them are coming down into their state. And you know they're going to go to the eastern part of the state. There's a lot better chance of clear skies. So anyway, that was 79. It was a morning eclipse, no clouds, and it was longer. This eclipse coming up will be my shortest eclipse, about 2.5 minutes. Okay, so the moon's only going to have a 70-mile wide path, so it'll do you well to get inside that path, not on the edge, because it won't be very dark on the edge. You want to get inside a ways, at least 20 miles or so inside the edge of the path. And it's going to travel across the United States pretty quick at an average speed, average again is the word, of about 2,300 miles per hour. It's going to enter the Oregon coast in what will be approximately our morning, but it'll finish up just 90 minutes later off the Atlantic coast north of Charleston. Just 90 minutes later. It's going to take 90 minutes to cross the entire country. The path of totality itself, the umbral shadow. So here's a picture. You can see the umbral shadow is going to touch down at 12:26 p.m. out here in the Pacific. It's when it's first going to make contact with the planet. By 1:17, it's hitting the Oregon coast. And by 2:48, these are all Eastern time because that's where we live. Wanted to make it simple. At 2:48 p.m., it's already going to be heading out to the Atlantic. And of course, the umbral shadow will lift off the planet at 4:02 p.m. So that's only 3 hours and 36 minutes of umbral shadow, the totality shadow, hitting our planet. And guess what? We're the only country that gets hit. There's a lot of ocean, but only one country and only our continent as well. So that should give you a pretty good idea of what's going to happen. Now, looking at this, almost the entire northern hemisphere and all the way down just about to the equator are going to get partial eclipse phases. The farther away from that blue center line, the lower your partial percentage. Asheville's going to get 99.2, and I'll talk to you in a minute about why that's still a failure. So here's a picture of what it looks like from space. This was the Mir satellite, predecessor to the ISS. That's the shadow. Now, the one thing I wanted to point out about this image is I hope it's not the way the shadow looks when it comes here, because you see what's underneath it, and we have a high chance of that here in our region of the country. But that's to give you an idea of what that umbral shadow looks like from space. I'm not going to run this video, but you can get online and find it. It actually shows the shadow, this interactive video, moving across the country from Oregon all the way out into the Atlantic. And you can see the towns it crosses. And of course, it's speeded up. They don't make you wait 90 minutes on this video. So it's a pretty nice video, but I'm not going to have time to actually run that through tonight. But here's a picture of our region. See Asheville by that red arrow? We missed it, 99.2. But it's not like school where you're ecstatic and you go home and, Mom, I got a 99.2. This is still a failure with eclipses. Just a partial. If you go inside this line right here, you'll get the total too. You get all, you don't miss the partial, you still get the partial phases, but you get that 2 minutes, 2.5 minutes if you're on the center line of totality, which is very special. The maximum time is 2:38 in our region if you're right on the center line. The longest any total solar eclipse can be is 7 minutes, 31 seconds. They're extraordinarily rare, and we'll talk about that in a few minutes. The longest I've seen is about 4.5 minutes, and that's a great one, really. As it's closer to the center line, the longer, of course, you're going to experience the totality. Okay, so here's a great interactive map. I'm not going to blow it up again. This is on our website. It's a NASA map. You click on it, and then you move the map and zoom into your region. It gives you every town, every location under the path of totality. You can click on it, and it tells you how much totality you're going to get. If you go into Clemson, you'll get 2 minutes and 37 seconds. If you go into Brevard, it'll tell you you're only going to get about a minute and 15 seconds. And it'll tell you when it starts, when it finishes. It's a great interactive map to help you plan where you're going to go. So, highly recommend getting on the website because there's a direct link to that and playing around with it. So, this event's about a 3-hour event if you count first contact when the moon takes its first bite out of the sun and then continues across to second contact when it creates totality, and then third contact when totality finishes, and last contact when the moon leaves the sun. So here you go. This is past first contact here. First contact would be right on the edge, but you can see the moon's taking a bigger piece, a bigger piece, a bigger piece, until you get to this section where you're starting to see the chromosphere. Here's totality with the corona, the outer atmosphere. Here's the diamond ring effect, which I'll talk about in a minute. And then you'll see that the moon is now leaving the sun's disk. This would have been, right in here would have been third contact. And when it finally leaves completely, that's fourth contact. 4 contact points. Okay, important distinctions between a partial and a total. Asheville's only going to have a partial. You'll only have to travel about an hour or less to get underneath that path of totality. Definitely worth it. Big difference. And you'll need to wear eye protection for the entire partial phases. And you can use these solar shades. You can go on our website. There's a place where you can use a cereal box and do a projection if you want. I've done that many times and just made one the other day with my granddaughter. We can use that cereal box to look at the sun today, but you won't see the moon taking a bite out of it. But yes, there are a lot of ways to do it. When you get these eclipse shades, if you don't already have them, you can use them every day. I had someone ask me, oh, I can't wait for the eclipse so I can use my glasses. Like, you can use them right now. The sun's there. You won't see an eclipse, but well, they say eclipse shades, so it makes you think you got to wear them during an eclipse. So here they are. They're very stylish. The way to wear these is you look down, put them on, and if you can see anything, throw them away. If you look down and put them on, you can't see anything, and you look up, you're safe to look at the sun. Look down and then take them off. So you're not staring at the sun. Don't use them for driving. And sunglasses aren't protection. Don't think your sunglasses are good enough. They're not. You have a question in the back?
Can you use them with your eyeglasses?
You put them over your eyeglasses because otherwise you'll see the sun, but it'll be a blur. You want it crisp. No, if you have prescription sunglasses, put them over the prescription sunglasses, put them over your prescription glasses. You can also use a number 14 welding glass. I have a nice pair of sunglasses that are welder's sunglasses. I don't use those for driving, but I use those. They're very nice. They're more stylish, and I wear those to watch the eclipse. And it's green. These will make it kind of a yellowish orange. So you can make it just about any color if you get the right filtering material. So
don't use those eclipse glasses behind the binocular.
no. Good point. If you've got optical equipment, put these in front of the optical equipment. If it's small, like an iPhone camera, you could put this in front of that little lens to take your picture. But not behind it, because it's, first of all, you're going to be taking your optics and exposing them to some pretty intense radiation, which you don't need to do. It's like taking a hand lens, starting a fire on some leaves. Everyone did that when they were a kid. I did. You don't want to do that to your optics. So during totality, the 2.5 minutes of totality, if that's what you get, some of you may have less than 2.5 minutes, take these off or you miss the show. The magic happens then, and you can't see it with these on. Take these off of your front of your binoculars or off the front of your cameras. You don't need these on your cameras during totality. That's when you can snap your pictures. But totality is going to be fast. I've been seeing 3 of them, and it doesn't matter whether it's 4.5 minutes or 2.5 minutes. They all seem to last seconds, less than a minute. So it's quick. Unless you're really good with your camera and have automated equipment, don't waste your time trying to take too many pictures, because before you know it, it's over and you miss the show, and I'm going to show you what you're going to miss. You'll need to wear protection, as I mentioned. Now, you'll want to, of course, magnification if you're going to take any pictures where you want to really see the sun. I'm going to talk to you about how small the sun is in the sky. It's pretty small. If you're going to take images during totality, of course, turn off your flash, because it'll be dark, and you don't need it. It's not going to reach the dark sky and light it up. It won't make it, I can tell you. They're good, they're not that good. So turn those off before you get to totality, so you don't make the mistake of taking a picture and blinding everybody around you. You're going to be very unpopular. With some magnification, you might even see some sunspots. The sun's near solar minimum, it's approaching it. There haven't been a lot of sunspots lately, but there's a nice group of sunspots just moved in right now. And I don't know what will be there on the 21st, because the sun's rotating, and these could be rotated off by then, the ones that are there, that were there this morning. Okay, I talked about taking your eye protection off during totality so that you can see the magic. Daytime will turn to dark. It won't be total darkness. This isn't one of the deeper eclipses. It'll be like a deep twilight. Again, when you get a much bigger eclipse in terms of longevity and being a longer lasting one with a wider path, it gets darker. Temperatures will drop. You'll definitely notice that. I've noticed that on every single one of them. I'm estimating somewhere close to 10 degrees around here. You'll see 4 planets in the sky if you look carefully. We have a chart on our website to show you what planets will be out at the moment of totality. Venus and Jupiter will be easy. They'll be far away from the sun, but bright. Mercury and Mars will be in closer. You'll be able to see those. And you'll be able to observe the sun's 2 outer atmosphere layers, which will be visible. The chromosphere, a very narrow atmosphere by comparison to the huge corona. Okay, corona is something you can only see during a total solar eclipse. The chromosphere, we in the club who have these cool hydrogen alpha filters, and the club has a couple of those telescopes. We can throw that on there and see the chromosphere with the red light and see the prominences. But I've never seen the corona except during totality. So special time to see that atmosphere. Here's a picture of what the sky will look like. During totality, you'll see the sun's there next to that bright star Regulus. See Mercury and Mars there near the sun. Jupiter, the upper left. Venus over to the right. Venus and Jupiter will be very bright. You probably will easily see those. And you'll notice one other cool thing. You're going to see that the sun is in Leo, the constellation Leo, and Regulus is the brightest star in Leo. Now, the sun is in Leo because going back into astrology, August is the sun sign for Leo. And that's the reason why it's the sun sign, is because you never see Leo during August because the sun's there blocking it between us and that group of stars during the day. Well, here's a chance to see Leo, the sun sign, right here during its eclipse during the daytime. So August is not a time, I happen to be a Leo, where I've ever seen Leo, not day or night, because it's the sun sign. So here's a chance to do something different. It won't be this dark. The program I got this from didn't let me change the sky darkness. It's going to be a lot lighter than that, but you'll still see the brighter stars and the planets. Okay, two sites you might see just before and just after totality, something called Bailey's Beads. The moon's not a smooth surface. It has mountains and valleys. So when that last bit of sunlight is coming through, you'll see it's bleeding through some of these valleys, and you're getting some beams of light that just haven't been quite covered up yet because it hasn't reached totality just yet. Just after this, you can take your shades off. One of the brighter responses to Bailey's Beads is this last bright beam of light that you frequently see called the diamond ring effect. It's really beautiful. You need your shades on for that, but as soon as that's over, take your shades off. Then as those come back on at the end of totality, put your shades back on. This is your key as to when to put them on and off. All right, so there's the picture of the sun. This is not what you're going to see, quite not like that in that size without a pair of binoculars, which I do have. I filter my binoculars for the partial phases about 5 minutes before totality, take those filters off, and I'm ready to look at the sun and see. We talked about the two atmospheres. There's the chromosphere, that red layer, see it, with the prominences? You'll see that, and out beyond it's the corona. Our eyes can't detect how far out the corona goes. It's a very tenuous atmosphere. It goes out millions of miles. We're only going to see tens of thousands of miles off the sun's disk here. But that is the picture with a pair of binoculars or a telescope you would see. The red prominences I talked about. And this is a long series of multiple exposures put together by a guy named Fred Espenek, famous solar photographer and imager. And we won't see that, but that's really what the corona looks like if you're able to capture enough images and stack them together. So how rare are total solar eclipses? I read a lot of these articles, and I wish they'd get editors, some of these writers. Someone who knew, they say, oh, this is a rare event. It's not rare. Guess what? There's one on Earth somewhere every 18 months. So we're going to have 68 of them this century alone. But there is something rare. It's rare when it comes near where you live. Think of our planet. 71% of the surface is oceans. Then you add in Antarctica and the Arctic area. These are all places people don't live, aren't going. So most eclipses don't occur in places you're going to be. And when they do, it's not normally at your home. It might be in Africa. It might be in South America. So what's rare is that it's coming near us. The last total solar eclipse that actually covered Asheville, and Asheville was just inside the totality path, was in 1869. So on average, the chances of total solar eclipse coming right over your home once every 400 years. That's not too often. Okay, that's an average. That means where you live, it might be 1,000 years. So, okay, so here's the deal. The most important thing, you usually have to travel to see a total solar eclipse, and there are people who do that regularly. They regularly go, they have a big expense budget for travel, and they're going all over. It frequently means they're on a boat, because remember, most of the surface is ocean. So you usually have to do some traveling, and I haven't seen one yet where I didn't have to travel. Even this one, I'm going to have to travel. This could be number 4 if we don't have clouds. But it's only going to be an hour. It's my shortest trip. I love it. So why and how do eclipses even occur at all? As seen from Earth, the moon and the Earth are about the same size. Even though the sun's the moon and the sun, even though the sun's 400 times larger, the moon's 400 times closer. So guess what? They cancel each other out and they cover up pretty well. This allows for the magic of a total solar eclipse. Okay, so if you take a pea, hold it at arm's length between your thumb and forefinger, you could cover the moon at arm's length. That's how tiny it is. Now, I wouldn't try that with the sun. Take my word on it, they're the same size, unless you're wearing your solar shades. So here's the entire sun's disk covered by the moon. Now here, I just told you they're the same size and they cover perfectly, but look what happened here. This is the moon trying to cover the sun, but what happened is the moon's orbit's not circular. It's an ellipse, so it has a near and far point. So much as if you put your hand in front of your face, you could cover up a lot of that screen, but as you pull it away, you can see more of it. So when the moon's near its closest approach to Earth, it just can't get the job done. It creates something special called these ring of fire or annular eclipse. The word annular comes from the Latin word annulus, which means ring, because you leave a ring. These kinds of eclipses are a hybrid partial, meaning you always wear your shades. You never take them off. This isn't even 99%, this one. It's closer to probably 80-something%. So the moon is, when it's nearest to its approach to Earth, which is perigee, that's when we're favorable for a total solar eclipse, and that's what's going to be happening on August 21st. It's near its closest approach. It'll cover the entire disk. Here's an exaggeration of its orbit so you can see how the moon orbits, and there's a near point and a close point. Total solar eclipses happen when the moon's over here near this point. If it's over here, you're going to get an annular eclipse. Okay, look at the difference in size. This is a great picture. You can see how during farthest approach, when it's at 253,000 miles, it's not going to cover the entire disk. Okay, here's a diagram illustrating pretty much what's going to be happening. People on Earth below this dark umbral shadow are going to get the total eclipse. Everyone in this penumbral area will get a partial. And this, I like this picture. I think it's a little more nicely done because it shows the partials really a pretty big area. These are the partial areas over here. A very large area of Earth gets partial. Okay, so why don't we get a solar eclipse every time the moon passes between the Earth and the sun? It's a new moon, you know, it's passing between. Why isn't it blocking it? The interesting thing happens is the moon and the Earth don't orbit on the same plane. I'm going to hold these two little embroidery hoops up. I have a domestic side. No, I'm just joking. It's not embroidery. The flat one is the Earth's orbit. The one that's high at the top and low, that's the moon's orbit. So most of the time, if you're the sun and I'm the Earth, and the moon comes between the two of us, it's up above our orbital plane. And it's a 5-degree difference. 5 degrees is big when the moon's only 1/2 a degree. That's a huge miss. All right, or if it's turned this way, it could be below. So it's either above or below, and we don't get an eclipse, we just get no moon, or what we call a new moon. Now, there are 2 points where the two orbits cross. They're called nodes. See here? So the moon is at one of these node points, and it's a new moon passing between you, the sun, and me. Then we're in perfect alignment. The 1/2 degrees line up. And guess what? We can have a total solar eclipse. So you need to not only be close, I talked about that distance, perigee, being close, you also have to be near a node point. So I hope that's clear. Those are two of the, this will be on the test, by the way. So you can see in the orbit here, only at the node points are you able to get a total eclipse. And these are favorable points, the node points. Up here, you have a new moon that's below. Over here, you have a new moon on the right side that's above, and you're not going to get a total solar eclipse at that new moon. All right, so 3 criteria for the eclipse. Here you go. This is a review for the test. All right, the moon has to be near perigee, closest approach, so it'll cover the entire disk. All right, and then you have to have a new moon, of course. It has to be between the Earth and the sun. And the last one, you have to be near one of those node points. And guess what? Here's the whole makeup of August 21st. We're near perigee. It's 3 days before, but still close enough to be a total eclipse. We're very near the new moon. New moon's at 2:30. Totality here is 2:37. But you're also near an ascending node where the two orbits cross. I talked about that with these embroidery hoops. It crosses at 6:34, so we're actually 8 hours after the crossing, but still close enough to have an eclipse. Now, if you wanted a mega eclipse, you would love to have perigee be on August 21st, not August 18th. And you'd love to have that crossing of the nodes at 2:30. Then you'd have a 7-minute plus eclipse. with a 150-mile wide path instead of our 70-mile wide path. That doesn't happen often, but fortunately, you don't need that perfect an alignment to still get totality. And that's why we have this one on August 21st. I hope that's clear for the test. All right, so here's the big thing, worse than the test. We live in the southeast. We have a very, very unlikely chance of getting clear skies at 2:30 in the afternoon on August 21st, but that doesn't mean we won't. It's just not very high, 45% chance. That's the average that I've seen it recorded. If you really want to get a better chance, might be too late now, but you should be going to Oregon, Idaho, Wyoming, where they have almost an 83% chance of clear skies and they're going to be seeing it earlier than 2:30. So in any event, being mobile helps a little bit, but I've also heard these horrible rumors about the traffic that we're going to experience on that day. Getting to places, millions of people. This is the most publicized total solar eclipse ever. They're thinking this will be the most observed total solar eclipse in history. And lots of people from Georgia, Florida, Virginia, Washington, D.C., all over are coming down our way to get underneath the path of totality. So,
Bernie, I heard stated that the South Carolina path is within a half a day's drive of 94 million Americans.
there you go. So we could have some gridlock that day. Okay, one other word of advice. Try not to pick a spot where you're near in a parking lot with these street lights that are around. Because they're on light sensors, you could wind up having this and you won't see the corona. You'll miss it. So go out where there's no lights. It's just those sensors are very sensitive. So I'd highly recommend avoiding the lights. If you've got a golf course or a grassy place, that's better. So again, look out for the lights. Now, if something happens, we get clouded out, or you decide you don't want to see totality this time for some reason, we have another one in 2024 that's coming through and it's going to be a longer drive. There's Asheville, so we're going to have to drive hundreds of miles to get underneath the path. But it's going to be a bigger one, 120 miles across, a little over 4 minutes of totality. And then, of course, this one 70 miles across in 2 minutes and 36 seconds or so, just for comparison. If you're going to stay in town, here's a couple of places if you want to just see the partial. I don't know why, but if you just want to see the partial, Asheville Museum of Science is doing a packed square. They're going to have a telescope, and you'll have shades and everything because you can't take anything off then. And they're going to be at Owen, North Buncombe, and T.C. Robertson High Schools. I heard the Arboretum's going to be doing it as well, if you want to go out to the Arboretum to look at the eclipse as well. So these will be partial only, despite the picture showing you this lovely prominence in the chromosphere. You're not likely to see the chromosphere at 99%. So there you go. Any questions?